This video gives a quick overview of AgenticNorm. AgenticNorm is a lightweight, log-only anomaly detection framework designed to discover semantic rules without source code or large proprietary models. The goal is simple: detect web tampering through interpretable constraints that can run locally and scale easily. The core idea behind AgenticNorm is to keep the interpretability of rule-based approaches while removing their heavy prerequisites. Unlike prior work, AgenticNorm eliminates source code dependence, avoids large cloud LLMs, and replaces handcrafted prompts with an automated refinement loop. This makes our approach far easier to deploy in real environments. Our method operates as a multi-agent loop. First, a constraint learning agent extracts rules from normal logs. Next, an attack generation agent creates adversarial logs that intentionally break these rules. Finally, a prompt refinement agent updates the prompt based on the missed attacks. Each round strengthens the rules, steadily improving accuracy without manual tuning. The constraint learning process begins by discovering relationships between APIs directly from logs. Instead of relying on program analysis, we infer these dependencies by observing how APIs co-occur in real execution traces. This allows us to recover cross-API semantics using only runtime data. AgenticNorm identifies related APIs using frequency analysis. By counting which API calls appear together across sessions, we infer meaningful behavioral connections, such as which APIs form a workflow sequence. This replaces static code analysis with a simple, robust log-based mechanism. Real logs are deeply nested and long, so we flatten all fields and group them into semantic clusters. Each cluster contains related fields that should be compared together. This reduces input from hundreds of thousands of tokens to just a few thousand, enabling small local LLMs to extract accurate constraints. Using these clusters, the system generates executable Python rules that capture consistency conditions, such as ensuring an order ID used in one API must match values returned by another. These rules form the backbone of interpretable anomaly detection. To improve coverage, we generate synthetic attacks based on the OWASP API security categories. The attack generation agent creates realistic tampering attempts that violate cross-API bindings, identifier checks, or field constraints. These adversarial cases expose gaps in the current rule set. The prompt refinement agent analyzes where current constraints fail and updates the prompt accordingly. It incorporates missing comparison rules, naming similarities, and range checks into the next iteration. Each refinement cycle expands the constraint coverage and enhances recall, while remaining fully automated. By repeating these three steps in an iterative loop, the system continually strengthens its constraints, leading to progressively better anomaly detection performance.